Today, we are going to be talking about proportional versus non-proportional relationships. Get that note packet ready and get your learning target filled in. I can tell whether a relationship is proportional or non-proportional. We have two definitions that we're going to cover. I've already got them filled in. I'm going to read them to you, and then you can pause the video to fill those in. What is a proportional relationship? A proportional relationship is a relationship in which two quantities have a constant ratio or unit rate. What is a non-proportional relationship? A non-proportional relationship is a relationship in which two quantities do not have a constant ratio or unit rate. Pause here if you need to, and you'll understand what those mean more as we go through our examples. So here's our first example. Our question is, how can I tell whether a relationship is proportional or non-proportional? We're going to use rates to unit rates, what we learned in previous lesson, converting those rates to unit rates, and then we're going to compare those unit rates. So we have Ryan here who earned $36 for mowing 2 lawns and $54 for mowing 3 lawns. Is this a proportional relationship? When you have problems like this, it's best to use a table to kind of organize your data. So I have my dollars earned, which is my dependent variable, and my number of lawns that were mowed, which is my independent variable. So the money that I earn, or the money that Ryan earns, actually depends on how many lawns he mows. The more lawns he mows, the more money he's going to make. Now let's look in the problem to see what we've got. We've got some key information here. He got $36 for 2 lawns and $54 for 3 lawns. All right, now my table is set up with 4 columns. So I'm actually going to skip column 1 because that would be for 1 lawn. And the sentence does not give us 1 lawn, right? But it does give us 2 lawns. So I'm going to start in the second one for 2, and that was $36. And it does give us 3 lawns, and that's $54. So what we're looking for here, for it to be proportional, is there would be a constant ratio or a constant unit rate. We know how to find unit rate. We set up the rate, $36 for 2 lawns, and then we divide by the denominator. 36 divided by 2 is 18, and 2 divided by 2 is 1. Now, for this to be proportional, our next rate would have to then simplify to the same unit rate. So this is our target rate here. So let's see if it does. I'm going to use a different color to set up this rate. It was $54 for 3 lawns. So this time we're dividing by 3. The denominator is 3. 54 divided by 3, you do that long division. 3 goes into 5 once. 5 minus 3 is 2. Bring down the 4, 24. Oh, yep, we get that 18 again. And 3 divided by 3 is 1. So we can see here, we do have a constant unit rate or a constant ratio. But this is actually a unit rate because we've got the units on it, okay? So what we would know then is there is a constant unit rate, $18 per 1 lawn mowed, so it is proportional. And we could take that, then we know that for 1 lawn, that Ryan's going to get $18, right? And we could go one further. How much would he get for 4 lawns? Well, if he's getting $18 per lawn, you do 18 times 4. And what is 18 times 4? Hopefully you said 72. Okay, so this is proportional. That's the key there. This one is proportional because we have that constant unit rate. Pause here if you need to. Let's look at another example. Kane County Cougars. It's a fun place to go in the summer to watch some minor league baseball. Kane County Cougars charge $7 per ticket plus a $3 processing fee per order. Is the cost of an order proportional to the number of tickets? So again, I'm going to set up a table to help me kind of look at this here. I know I'm comparing cost to the number of tickets. And my cost depends on how many tickets I buy. So cost is the dependent variable. Tickets is the independent variable. All right, so let's look in the problem here. The Cougars charge $7 per ticket plus a $3 processing fee per order. All right, so that means if I'm just going to order one ticket, it's $7 for that ticket, but $3 processing fee for the order. So how much would that be? That would be 7 plus 3 or 10, right? Now, what about if I order two tickets? If I order two tickets, we know that for one ticket, it's $7 plus the 3 for the processing. So that's like 10. Another ticket would just be another $7. So we're just taking ticket 1 and then we're adding one more ticket. So that would be 17. We don't have to do the processing fee again. That only happens once when you order. So 3 tickets. 3 tickets, we would be taking that $10 for the one ticket and the processing fee, and then add 2 more tickets onto that, which would be 14. So that would be 24. And then 4 tickets, that $10 fee for the one ticket, $7 plus the processing fee. And then 3 more tickets at $7 is 21, so that would be 31. All right, so is this proportional? So basically what we're trying to see is if we look in this first column here, we've got $10 for one ticket. This is our unit rate here. If it's proportional, all of these other rates will match this unit rate. So let's test it. We've got $17 for 2 tickets. I'm going to divide by 2 to get to my unit rate. 17 divided by 2, if you punch that into your calculator will show you 8.5, but we know money goes 2 places, so that would be $8.50 for one ticket. Now, right here, you can see that the 2 tickets do not match the one ticket. It is not the same constant rate of change. So because that is true, we can stop doing our math right there and say, the cost of an order is not proportional to the number of tickets. There is no CROC. What does CROC stand for? Well, if you don't want to write it out, I'll be happy to accept CROC. That stands for your constant. The first C is constant. R is rate. O is of. And the second C is change. So there's no constant rate of change. There's no constant unit rate. $10 for one ticket, but $8.50 for 2 tickets. They don't match. Pause if you need to. Is this table below showing a proportional relationship? Okay, so we've got earnings and time. This time we're doing earnings and time. Earnings is dependent on how much time you spend doing whatever. So the more time you spend, the more money you're going to earn. Dependent variable earnings, independent variable time. All right, so we've got 18.1, 36.2, 54.3, 72.4. We've got to find those unit rates, right? So if we look at the first one, $18 earned for 1 hour. This is our unit rate. This is what we're trying to match. Set up your second rate. $36 for 2 hours. Divide by 2. Divide by 2. And that gets you $18 for 1 hour. It's a match. All right, so we got one match, so we need to keep going. So our next one is $54 for 3 hours. Divide by 3. Divide by 3. And that is also 18 for 1 hour. It's a match. So we got to test that last one. I left myself no room. I'm going to do it over here. $72 for 4 hours. Got to find the unit rate. So divide by 4. Divide by 4. What does that simplify to? How much per hour? 4 goes into 72 once. 7 minus 4 is 3. Bring down the 2. Oh, yeah, that's 18. They're all 18. So what would we say here? We would say, yeah, yes, this The constant rate of change or constant unit rate is 18 per hour. So this is proportional. Is this table showing a proportional relationship? Yes. Okay. It has a constant unit rate or a CROC, a constant rate of change. Pause if you need to. All right, last one. At the beginning of the year, Katie has $120 in her bank account. Each week she deposits 20. Is her account balance proportional to the number of weeks of deposits? All right, so my table this time is comparing balance, account balance, with time, and we're measuring time in weeks. So my balance depends on how many weeks I've been contributing money, right? Balance is your dependent variable. Time in weeks is your independent variable. All right, I've already got my weeks filled in because I'm counting the weeks, 1, 2, 3, 4, right? So we need to look back at the problem here and pick out what we know. And what we know is Katie has 120 in her bank account, so that already exists. And then for each week, she's going to deposit $20 more. So when we start this out, this is kind of like that Cougar ticket one, right? We're at 120. She already has that, but at week 1, she's going to add 20 more. So what would that be? 120 plus 20 is 140. Okay. And then at week 2, she has 140. She's going to add 20 more. 140 and 20 is 160. And then at week 3, she's at 160. She's going to add 20 more. 160 plus 20 is 180. And then at week 4, she's at 180 and she's going to add 20 more. Oh, and that brings us to a nice even 200. Okay, so what we got to see is there a constant unit rate, a constant CROC here? So if we look at week 1, which will be our unit rate, we've got $140 for 1 week. So this is our target. This is what we're trying to match, okay? So week 2 says $160 for 2 weeks. So I'm dividing by 2. Half of 160 is 80. 2 divided by 2 is 1 week. Right here, these don't match. $100 or $80 per 1 week, and this says $140 per 1 week. So is this proportional? Is there a constant unit rate? Is there a CROC? Absolutely not. The account balance is not proportional to the number of weeks of deposits. There is no CROC. All right. Those are our examples. Now we're going to practice.